For so long a time, there has not been an open source PS1 SDK that is capable of pushing 3D graphics as good as what you're seeing right now. Until recently, that is. Hello, this is Lenga64, and I guess this video is quite late to the party because I've actually released PS1 SDK all the way back in April 6, which is roughly within the estimated schedule I stated in the scroll text of Noob demo of when I will release PS1 SDK to the world. I was going to make a video about PS1 SDK shortly after the release, but life got in the way and I wasn't able to make a video for quite a while until now. Damn life. But anyway, what's important is I finally got this video out. Otherwise this video won't be on my channel whatsoever. But anyway, as the name suggests, PS1 SDK is my very own SDK project for the PS1. Yeah, I've actually gotten so good at programming the PS1 that I started making my own SDK project. Though I had my own motivating reasons why I pursued such a project, and it's beneficial for pretty much any PS1 related project that I'll be working on, including Scarlet Engine, previously known as Project Scarlet. I decided to do a name change now because, well, Microsoft took the name Project Scarlet for the next gen Xbox, so yeah. And I haven't actually worked on that engine for a while because I've switched focus on PS1 and then PS1 SDK. But I feel those are still good projects anyway, that would benefit Project Scarlet in the end anyway. So yeah. I'm not sure if I mentioned this, but I did use other open source SDK projects that have come and gone on the PS1 as a reference, such as PSX SDK. But most of the implementations in my SDK are written from scratch. So yeah, this is taking a bit long already. Enough rambling, I'll get on with it. This project, much like PS00bDebugger, also started out as an experiment once upon a time. The experiment eventually evolved into a test to see if it's possible to make an SDK that is on par to the official SDK in terms of how it utilizes the hardware, as all other open source SDKs for the PS1, such as PSX SDK, often don't really do a good job at such things. I use the GNU GCC toolchain that's been configured to target the PS1 CPU as the foundation of my SDK, as it provides not only a C compiler but also an assembler. This is just a bare compiler, as in there's no standard C libraries or libraries for doing things on the PS1. While I've had some problems with it during the development of Noob Demo, which I've yet to confirm if they are compiler bugs or not when optimizations are enabled, it's pretty much the only good option to a free compiler that can target the MIPS R3000 platform that I'm aware of. I still hate how something so industry standard as GCC is so poorly documented in my experience with it. I guess that's part of the FOSS experience, I suppose. The reason why I named PS1 SDK with the noob is, well, more or less the same reason why I named PS1 with the noob, in that this is also not exactly professional software, and that this project is still far from production ready. Heck, controllers and CD-ROM support isn't even implemented yet. Oh wait, the SDK just got controller support recently. Man, this video is really long overdue. Aside from the BIOS tests, the very first thing I got working on my SDK was the GPU, to display an image in high resolution mode. While the program shown here is not the exact one I made a long time ago, it works in a very similar manner, only that this one displays an image in 24-bit TrueColor instead of 16-bit. Texture data is uploaded to VRAM using DMA in both the original test program and this one, which explains the somewhat instantaneous transfer of a nearly 1 MB image to VRAM. Shortly after that test, I got to work on implementing GPU DMA ordering table drawing and vertical sync at the same time. Both were pretty tricky to get working properly, especially on real hardware, but I eventually cracked both of them in the end. VSync is implemented by installing an event handler to the kernel that is triggered on every VBlank, but the most preferred method of handling vertical sync, along with other interrupts, and is one used by the official SDK, is by hooking a global interrupt handler to the kernel, which I've yet to get working properly someday. Oh, that was also recently implemented as part of getting the controllers to work, to some degree at least. Man, I really have to get this video out soon. Of course, I was the one who made the new implementations, obviously. Once I got those things sorted out, I started implementing support for graphics primitives, starting with solid color sprites. Then, textured sprites. These were one of the more simpler things to implement for me, as I was already very familiar with the graphics primitives of the PS1. I also added some additional code to the vsync function to wait for the interlace field of the GPU status to toggle right after vblank. If you don't do this, the GPU will only draw to the first field, so beware of that if you plan to use high-res mode in some low-level PS1 programming project. If you haven't noticed by now, the majority of the libraries of PSn00bSDK are written in pure MIPS assembly, for both speed and size reasons. I always thought it is best to write functions that fiddle with hardware registers in assembly instead of C. Writing functions that touch such registers in C always gives me a feeling of uncertainty for some reason. And while I'm talking about libraries, most of the APIs, such as structures and function calls, deliberately resembles the API of the official SDK as close as possible. Mainly for familiarity reasons, but to also make it easier to port existing homebrew made with the official SDK, whether it be PsyQ or NetYaroze, provided the functions it depends on have been implemented. Once I got Polygon primitives working, I quickly moved to getting GTE support implemented. While writing graphics code that utilizes the GTE is a pretty trivial feat for me, figuring out the math to calculate rotation matrices was occasionally a pain in the ass, especially when I wanted to make the output as close to what the matrix functions in the official SDK produces. Firstly, I needed to implement a sign function, as that is absolutely mandatory if you want to rotate things around. Obviously one that returns a fixed point integer value, as the PlayStation lacks a floating point unit. Obviously this is not the reason why the console has problems with texture mapping, like what some uneducated people would say. I settled with a Taylor series implementation described in this article that appears to be made when DS Homebrew was all the rage, as it includes not only an implementation in C, but also in ARM assembly. This was the best implementation I could find, as it's pretty short, doesn't use tables, and most importantly, returns fixed point integers. The function can also be tweaked to increase the precision of an angle, at least as far as what fixed point math can handle. It took me a bit of reading to figure out how to compute a 3x3 rotation matrix, but eventually got my own rot matrix implementation working, and some spinning 3D polygons. I also implemented a higher precision high rot matrix function, which uses the higher precision high sin and high cost functions for achieving finer rotations just for the heck of it. Next, I worked on implementing a couple of special matrix functions so I can do a first-person perspective with a camera I can fly around freely. Speaking of which, I was originally going to have something like that in Noob Demo, where you can fly around the bunny girl model, but I didn't have working controller support at the time, and I didn't want to use a rather crude implementation that requires manual polling. Along the way, I also implemented some support for the SPU, but I only gone as far as implementing very basic support for it, such as uploading samples to SPU RAM via DMA and playing SED sounds, as I was more focused on the graphics side of things. I may work on the SPU stuff more when I get around to doing more audio related stuff on the PS1 in the future. I eventually reached a point in my SDK project where I can finally do some fancy stuff on the graphics side of things. I prioritized working on the graphics front the most ever since I started working on this project, as that's something a lot of other open source SDK projects are most lacking at. This is also the point where I started developing Noob Demo, which I intended to make as a simple graphics demo to not only show off my PS1 programming skills I've earned in the last few years, but to also show proof that making an open source SDK project for the PS1 that doesn't suck is absolutely possible with enough effort. I was originally going to release Noob Demo sometime in Christmas of last year, but I wasn't able to meet that schedule due to certain things taking longer to develop and life getting in my way as per usual. I would most certainly love to be in this situation where it's just me and my projects, but I can't, as I don't want to end up like one of those who try to make a living off of YouTube and DisplayPort yawn, and I'd much rather have a real job and be able to talk shit and dot cropped hentai in my videos, which I actually drew by the way, than doing shit just to please the ad providers. You lose some, you win some, I guess.
Majority of Noob demo was written in C, with some of the more intensive stuff, such as the model and mesh rendering routines, written in assembly, making this a mixed language affair which is still perfectly within my standards. The point lighting demo was actually written entirely in C, with a bunch of inline assembly macros dotted around, as this was more of a prototype I made while I was figuring out how to achieve point lighting on the PS1. Now that I know the algorithm, I should be able to make a version written entirely in MIPS assembly, which would most certainly run a lot faster than this C implementation. Perhaps in a future demo or possibly a rendering feature for Scarlet Engine. This is not the first time point lighting was achieved on a PS1, as Silent Hill and a few other games did a similar lighting effect much earlier. And there you have it. I guess that's pretty much most of what there is to say about PSn00bSDK, for now at least. I'll leave the rest to that tit who mumbles in front of the camera.
Well, one of the bigger limitations of PSn00bSDK, as of the making of this video, is it currently lacks C++ support. While a C++ compiler is available, the problem is it's missing something to get those features working, like classes and new delete operators. And if you compile some C++ code with some classes in it, it would compile fine, but when you start linking them together, you'll notice that the linker is throwing a fit at missing functions, which is what the C++ features are depending on. The problem is I couldn't figure out how to get C++ to work. I read that it might have something to do with getting ulib set up first, or glibc, but I couldn't find much documentation on how to configure ulib for a specific target, in my case the PS1. I know you have to supply your own functions for certain I/O operations, but I haven't figured it out yet. This is not the only open source SDK project that has this limitation. Other open source PS1 SDK projects like PSx SDK also don't have C++ support, and some projects for the N64 also don't have C++ support oftentimes. So yeah, I guess that's part of the FOSS experience with documentation being very vague or limited. What do you expect? I'll eventually try to figure it out because I want to have some C++ support in my SDK. I don't necessarily need a full standard C++ implementation. I just need something that's enough to get classes and those new delete operators to work. Maybe some standard string and standard vector support is to some further extent, but I don't need the full C++ support, because you have to remember the PS1 has only 2 megabytes of DRAM, so having a full C++ runtime library may result to quite a significant amount of bloat, which you don't want on a system that's quite limited in the amount of memory it can store. So yeah, another thing about PSn00bSDK is I'm still working on it. In fact, because this video took so long to make, a number of the previously inherent limitations of my SDK, which I've explained in the original draft of this video, had since been patched, like the controller and the CD-ROM support. Granted, I'm using the BIOS functions, but that's better than no support at all. So yeah, you would have most likely noticed it while watching the video, because I've put in clips that address those things. So yeah, recently I've got a very good interrupt service routine working that uses the set custom exit from exception hook to guarantee that that handler gets executed whenever an interrupt occurs, and you can detect the interrupt yourself in your handler. Once you've installed your custom handler, you must call change clear pad with 0, and then change clear rcnt with 3 and 0. That would disable the kernel from automatically acknowledging the interrupt for vblank, which the pad driver uses in the kernel, and then the change clear rcnt would turn off interrupt acknowledge for the timers. So yeah, keep that in mind if you're planning to do some low-level PS1 programming yourself and want to handle interrupts the proper way. I've also been working on implementing serial support as well as siocons so that printf messages will be relayed to the serial interface so it can be viewed on a serial terminal on the PC side. And also it would allow me to port light load from the official SDK to PSn00bSDK, making it a 100% free and open source loader tool for the PS1. So yeah, once I get serial stuff working, it should open up a bunch of new possibilities as well as siocon support so that files from the PC side can be read through serial. It'll be slow, but it's better than nothing, I suppose. And I'll also look into figuring out how to get higher data rates to work properly with the PS1 serial interface, because from my past observations, the serial interface of the PS1 can actually do 230,400 baud, which is twice that of 115,200 baud. It can actually output those bytes at that rate pretty okay, because I've had serial, my USB TTL adapters can receive the values properly, but last time I tried to send data to the PS1 at that data rate, it was quite unstable. I'm gonna figure out a way to make it more usable and more stable, I suppose. One of the more annoying things that I haven't worked on with PSn00bSDK is, well, documenting the whole thing. I've been using LibreOffice to document it, but I've had issues with LibreOffice, like in the Windows version. If you try to open up any dialog that loads up fonts, it would stall for sometimes a good minute. So, and also another annoying thing is that headers don't get parsed properly by the automatic table of contents generator. So that one's really annoying. And the most annoying thing about it is no one else seems to be having this issue. I was considering using DocBook to document it, but I feel it looks a little too basic for my documenting for the kind of documentation I wanted to do. And I've also considered as what was that? Doxygen. I cannot use Doxygen because I don't want to litter my header files with Doxygen blocks. I don't know, Doxygen is quite messy on the source code side. I'm not a fan of it. But I'll try to get around. There's an incomplete library reference document, but it only covers a portion of the graphics library. It doesn't cover the other libraries like GTE and other things. I've been working on another revision of that document that's more consistently, more carefully formatted, so it'll be a lot less annoying to manage. So about that photo where I'm holding up a Casio CC5000, well, that's actually real. I actually now own a Casio CC5000. I got it from a local surplus store for just roughly about $110, which is quite a bargain considering that these keyboards usually go for upwards of the higher 3 figures, or if not the 4 figures already by now on eBay. So it's still quite pricey, but well, if you compare it to eBay prices, it's quite a steal. I don't plan to do a video of it anytime soon because I first need to learn how to use it properly, because I don't want to represent it incorrectly and essentially be like one of those duders who are like, oh, look at this, I spent a whole fortune for this Casio CC5000. Oh, look at this, it looks so cool with all these buttons and things all over it and lights and whatnot. It's missing some dials, but it's okay. It's the CC5000. It's a famous synthesizer from the 80s. Let's go play something on it. Oh man, it sounds so cool. Oh man, it sounds so cool. Yeah. Oh yeah, it sounds so cool. And not make any music with it whatsoever. So yeah, I'd rather learn how to use the CC5000 first before I start making a video about it. I usually use it with a sequencer, more specifically a Pentium 3 Tri-Gem computer as a sequencer, and a MIDI cables. I've been merely just testing out MIDI playback with the CC5000, but I'll eventually try to make my own compositions. I'd probably just do upgraded renditions of my old music using the CC5000. And also the YMF724 sound card in my Pentium 3 Tri-Gem I'm using as a sequencer, because that one has some limited XG capability and doesn't really have anything special to it, but it's still useful if you want like some MIDI percussion. Really, it's good enough for drums, considering the CC5000 can't really do percussion, so yeah, it's better than no percussion at all, I guess. I also have a Korg Poly 800 I got quite some time ago. In fact, I've used that to make the intro music in my videos, so with I think a custom program. But yeah, I might also try to make music with that as well, probably alongside the CC5000. I don't really consider myself as a musician. A musician. I'm more of just a tinkerer, really. Much the same way as how I don't really class myself as an artist. I'm just some fool who knows how to draw, really. So yeah, I don't really want to go back to the art community anymore. Apparently I'm too stupid to be there, so turning my back on that field is probably one of the best decisions I've ever made. I've been considering changing a few things about my videos, starting with the new Lame Guy 64 intro that now has volumetric lighting, and it's now rendered at 60 frames per second. Because I'm planning to target 60 frames per second as consistently as possible these days. But the most annoying thing about trying to achieve that is because the camera I'm using, it's a Panasonic Lumix LX7, it can only record PAL frame rates like 25 and 50, not 30 or 60. So what I do to get around that, because Kdenlive is so high-tech, it cannot do motion interpolation for frame rate conversion, I first have to like trim down this video with using Kdenlive, and then output render it as a 50 FPS video, and then I would run it through FFmpeg because it has a pretty good motion interpolation filter. But the problem with that motion interpolation filter is it only uses a single thread, so it's very slow. So yes, hence why I had to like edit down the video that I'm gonna upsample to 60 FPS first before I because because in my clips I often have like a bunch of junk clips, so if I were to just interpolate all of that at once, it would take forever, because, well, and then most of the clips that got interpolated, the junk clips in particular, won't really be useful anyway, so better trim down the fat before running it through some really slow interpolation process. So yeah, not only that, I'm planning to replace the artwork that I've been using in my thumbnails and also in the end card of my videos. That artwork was drawn by Lumdrop as a great gift for me. So I really appreciate that, but I wanted to make my production values a bit more original, as in all of the assets would be made more or less entirely by me. So yeah, I really like your art, Lumdrop, but I want to be a bit more original soon. I would have been able to use it more if it wasn't for my hiatus that happened back in 2018 because of stupid, I'll just put it that way, because it really is stupid. So yeah, so in case you're watching this video, Lumdrop, I really like your artwork, but yeah, I want to have my own artwork as well. And since I'll be making my own drawing of my characters soon, I'm probably also going to need to dust off my old Wacom intros and start sketching. Yeah, that's the thing I don't want to like do in my videos. I want to make things as original as possible and draw everything that I need for my videos all by myself. And it gives me I sort of feel like I have a bit of an edge that I actually know how to draw things, even though I don't consider myself an artist. I'm just a drawer, not like a drawer who draws things, like a cabinet, really. I guess that's pretty much it for this video, and I think that the music that you you've been hearing after I rambled about my Casio CC5000. That's Dream Express from Toho, which I've synthesized with my Casio CC5000 as a test. So yeah, I guess that's pretty much it for this video, and I hope you enjoyed watching it. Also, before I end, I should mention my Discord channel. It's not really a Discord server. It's a channel. Otherwise, if it were a server, I would have been able to like self-host it, but that's not how Discord really works. So it's enough rambling about that. So yeah, I have a Discord server. If you want to annoy me directly, or if you want to just have a chat with me, really talk about PS1 stuff, and maybe possibly learn how to do PS1 programming from me. Speaking of which, I also have my own website up and running. It's at lameguy64.tk, and I have pretty much most of the things I've made, mainly development tools and some software. I haven't put up a page of PS100bSDK yet. I have to, speaking of which, I have to like rewrite it quite significantly first. But the thing I have on my website is I'm actually working on a tutorial series for PS1 programming that focuses on programming with either the official Programmer's Tool SDK or PS100bSDK. You can find that in my website. So there isn't really much yet at the moment because it's still a work in progress. But you can find everything that I've made so far on there. So if you want to get into PS1 homebrew programming, why don't you take a look at that tutorial series. So yeah, I guess that's all there is left to say. So if you like this video, leave a like, comment, share, or subscribe if you want. And as always, thanks for watching. LameGuy64 is signing out, and have a good day.